Alright, so in this today's session, we'll try to solve the problem number 10 for project Euler. So let's read the problem. Problem number 10 says, the summation of the prime number below 10 is 2 plus 3 plus 5 plus 7 is equal to 17. So find the sum of the all prime below 2 million. So if I say the upper limit is 10, then the summation of the prime number below the 10 is 17. So what will be the summation of the prime number where upper limit is 2 million? That's our problem. So in order to solve this problem, let's jump into coding. In order to solve this problem, I think we'll need few functions. Okay. So first function, I think we have defined a function called is prime in problem number 3, where that function will give you whether a number is prime or not. Okay. So I've just coded this function for problem number C. Please have a look into it. For now, what I'll just do for convenience, I'll just copy this function. Okay, I'll not code it again. I'll just quickly explain how it works. So this is prime takes a number and it will return true if the number is prime, otherwise it will return false. Now we'll have to check for each number whether it's prime or not, but we don't have to check on every number. First of all, we know the if number is even, then they are not prime. Okay, so I know number 2 is equal to prime, but other than 2, if number is divided by 2, then it's actually false. Basically, it cannot be prime. And we don't need to check from 1. We can check from 3 and with the increment of 2. Basically, we can check the 3, 5, 7, 9, whether they are prime, whether they are divided by the number or not. Okay, so number could be anything. It's a 500 or something, and we'll check from 3 to 357 whether that's divided by any of this number. If it is divided, then number is not prime, otherwise number is prime. However, we don't have to check until the whole number. We can check up to the square root of that number. That's what is done here, number to the power 0.5. So that's the is prime. Let's check if it's working fine. So I'll just check like 5 is true. If I check 6 is false, and if I check 101, let's say, it's true. If I check 103, it's true. 105 is false. Okay, so that seems to be working. Now what I will do is we need one more functions which will give us the next prime number. So let's say if I give a number 4, it should return me 5 as a next prime number. Again, that was solved for problem number 8, and again I'll not code that one right now. I'll again copy that function. So the next utility function that I will use is this get next prime. So what it does is it takes the number, it checks if number is even, then I will just increment is to 1 so that the number becomes odd. Then we'll continue checking. If the number is not prime, keep incrementing number as 2. That means if we started from 3, we'll increment it 5, 7 like that until we get the number as prime. When we found it, we'll break out of this loop and we'll return that number. So let's check that number again. So if we test this number, get next prime, say 6. Okay, so it will give me 7. But if the number is already prime, it will give me the same number. Okay, that should be fine. So if I give 9, I get 11. So we got these two functions. Now for our problem, basically we'll set a upper limit, and with that upper limit we want to get all the numbers by that upper limit, and we need to sum for all of the prime number below some upper limit. Okay, so let's create a new function. Okay, function is get, let's say get prime sum. Okay, and we give a upper limit. Okay, now we'll start with the prime sum. Let's say prime sum will start with 2 because we know the first prime number is 2 and I'll not check that. Then I'll just create another sum variable as 0. Then what I'll do is while prime sum, well actually this should not be prime sum, this should be prime number. Let's say I'll say prime number is equal to first prime number is 2. Then what I want to do, and say if prime number is less than upper limit. So while prime number is less than upper limit, we'll try to find the next prime number, and once we find the next prime number, we'll keep on incrementing our sum. Okay, so sum plus is equal to prime number. Okay, and first prime number we started with 2. Then we'll update our prime number. Will be our get next prime number. So we'll get next prime number, and we'll just do the prime number plus 1. Okay, so that we get the next prime number. Otherwise, if we keep the prime number, we'll keep get the same prime number. Okay, now let's return the sum. Okay, now let's test this function. Get prime sum 10 is 17, and I think that's what it says. Yeah. So again, this function is very simple. We are starting with a prime number, which is the first prime number 2. Then we have a sum variable. Keep trying to get the next prime number until we got our limit, and then we are continuously adding the sum with the next prime number. Okay, so that's our problem. So basically, yeah, that's what we have done. Now the problem says, what is the sum of all prime number below 2 million? So let's try 2 million. 2 million is 230, another 30. Okay, so we can keep underscore just so that it's easier for us to count. Okay, now let's try to get this number. Okay, so here is the number. Let's see if this number is working fine. Okay, whether this answer is correct. Let's check that. Yeah, the answer is correct. Okay, so I think that's it for the current session. Thanks for watching. Please, if you like my video, please click on like and please share. And coming up next is problem number 11. Okay, thanks again.